All right, let's get right into it. You've probably been hearing this term floating around, context engineering. And look, I get it, another buzzword, right? But stick with me, because this isn't just hype. We're going to break it down for what it actually is, a real engineering discipline for building AI that, well, that actually works. If you're tired of just playing with prompts and you're ready to architect a real AI application, then you're in the right place. So, let's just start with a question that I think we've all screamed at our computers. Why are these AI assistants so forgetful? You know the feeling. You're deep into a problem, you've laid out all the details perfectly, and then on the very next message, the AI has absolutely no clue what you're talking about. It's frustrating, and it's the exact problem we're going to solve.
This really hits the nail on the head, doesn't it? Our expectation is this smart collaborator, this partner that remembers what we're doing and helps us build on our ideas. But the reality? It's often just a stateless tool. It takes an input, gives an output, and then poof, memory gone. That's the huge gap between a fun tech demo and a tool you can actually rely on.
Okay, to fix this, we need to put our engineering hats on. We're going to architect a system starting from the ground up with the absolute fundamentals. We'll use a little biology metaphor here, starting with the smallest pieces of the puzzle, what we'll call atoms and molecules. So what's an atom? It's the absolute simplest thing you can do with an LLM. And for all you backend folks out there, think of it exactly like a stateless HTTP request. Seriously, you send a payload, which is your prompt, and you get a response back. The server has no memory of who you are or what you just asked. It's a total one-and-done transaction.
Let's use a running example. Say we're building an API support bot. At this atom level, it's okay. It can answer a simple, self-contained question, like, what does error code 401 mean? But the second you try a follow-up, something like, okay, so how do I fix that for the endpoint I told you about before, it's completely lost. It has no idea what before means.
So how do we get smarter? Well, we start combining our atoms into molecules. And a molecule is where things get interesting. It's a structured context where you don't just tell the AI what to do, you show it with examples. You might have heard of this as few-shot learning, and it's our first big step toward building something truly intelligent. Here's exactly what that looks like for our API bot. Instead of just vaguely asking it to parse some error log, we give it clear examples. We show it, when you see an input that looks like this, I want a structured JSON output that looks exactly like this. By seeing a couple of these patterns, the model learns what to do, and suddenly our bot becomes way more reliable. Now, at this point, you're probably thinking, hold on, this just sounds like a fancy way of saying prompt engineering. And you know what? That's a totally fair question. We are crafting a prompt here, but what I want you to see is that this is just the first tiny piece of a much, much bigger system.
And here's the key difference, right? Prompt engineering is all about tactics. It's about finding the perfect magic words for one single request. It's important, but it's small scale. Context engineering? That's architecture. That's you, the back-end engineer, stepping back and designing the whole system. We're talking memory management, integrating tools, and orchestrating how information flows over a long, complex conversation.
All right. Now for the part that changes everything. This is where we make the leap from a simple script to a real application. We're going to add memory by building what we'll call cells.
A cell is simply a structure that maintains state across multiple turns. And again, for a back-end engineer, the analogy is perfect. Think of it as a user session. It's a dedicated space where you can store information that needs to persist from one request to the next, giving the whole conversation a short-term memory. Just look at the night and day difference this makes for our API bot. With a memory cell, it can now remember critical info, the user's API key, the exact endpoint they're fighting with, the last error code it saw. All of a sudden, the conversation makes sense. It's not a bunch of disconnected questions anymore. It's a real, flowing debugging session.
Of course, as any good engineer knows, as soon as you add state, you create new problems to solve. The big one here is resource management. These models have a finite context window, basically a limited amount of memory. So what do you do when the conversation gets really long and you're about to run out? Well, this isn't some weird AI magic. It's a classic engineering problem, and we can solve it with classic engineering solutions. You could use a simple sliding window, just keeping the last 10 messages, for example.
Or you could have another AI call that periodically summarizes the older parts of the conversation. And my personal favorite for back-end systems, extract the most critical facts, like the user ID or API key, and store them in a structured key value store so they never, ever get lost.
Okay, so we've got memory, we've got stateful conversations. Now let's scale this thing up. Let's go from a single stateful application to a whole coordinated system of them. Let's build organs.
An organ is just a system of specialized cells that all work together. And the parallel here for a back-end developer is just too good. This is a microservices architecture. Instead of one giant, monolithic AI that's supposed to be good at everything, we build a bunch of smaller, specialized AIs that are each really good at one specific job. And this is where our API bot gets really powerful. Check out this workflow. First, a router cell, and you can literally think of this as an API gateway, gets the user's question. It figures out what needs to be done and then calls other specialized agents. It kicks off a doc retriever to go pull the right API docs. Then a code generator actually writes a little script to reproduce the bug. Finally, an evaluator cell analyzes that script's output and figures out the solution. See what's happening? This is a full-blown automated back-end process, a microservices architecture, just powered by AI. Now, everything we've talked about so far treats context like structured data we can manage. But let's zoom out to the most advanced, maybe even a little theoretical layer of all of this. Let's start thinking about context as a living, dynamic landscape. This is the idea of fields. The idea of a field is a pretty big mental shift. Instead of thinking about chunks of data sitting in a database, imagine context is more like a magnetic field, a continuous space where meaning isn't just stored, but it flows, it has direction, it has intensity, and it organizes itself. And this kind of thinking opens up some really cool concepts. Attractors are like points of semantic gravity that pull a conversation toward a coherent topic. Resonance is how patterns can reinforce themselves without you needing to explicitly save them in a database. And the holy grail here is emergence, where complex, intelligent behaviors start to appear that you never explicitly designed, all just from the interactions within the system.
Whew, okay, that was a lot. But we've gone on a huge journey here, right? We started with a single, simple prompt, and we've worked our way all the way up to architecting these complex, dynamic systems. So let's just quickly recap the toolkit you now have. This is it. This is the context engineering stack. You start with stateless atoms. You group them into molecules with examples to guide them. You add memory to create stateful cells. You orchestrate those cells into powerful, microservice-like organs. And you can even look to the future with self-organizing fields. This isn't just a list of buzzwords. It's a step-by-step roadmap for building smarter and smarter AI systems. And this quote from Norbert Wiener, the guy who's basically invented cybernetics, just says it all perfectly. The real magic isn't in the individual prompts, the atoms. The real power, the intelligence, comes from how you architect the relationships between them, the memory, the flow, the whole system. So I'll leave you with this. As a back-end engineer, you already know how to build robust, scalable systems. That's your bread and butter. Now you have a framework to apply those same skills to building with AI. So if you can control an AI's entire context, its memory, the tools it can use, the other AIs it works with, the question isn't, what can a chatbot do anymore? The question is, what truly intelligent systems will you build?